Hi, folks. My name is Roshan Padmanabhan. I'm a Senior Program Manager with the Microsoft 365 Customer Experience team. Welcome to the Microsoft 365 Network Connectivity video series. In this video, we're going to talk about network connectivity for remote users. First of all, why is this subject even relevant? Well, network connectivity for remote users plays a critical role in facilitating continued employee productivity during large-scale work-from-home events such as the COVID-19 crisis. That's why this subject is important. We're going to look at the following topics during this video. First, we'll start with M365 network connectivity principles, and then we'll spend some time to understand the requirements of a remote user in terms of connectivity and experience. From there on, we'll look at what is VPN split tunneling and why is this relevant for remote user connectivity. And then we'll spend some time discussing the Office 365 network connectivity guidance for remote users, support from VPN vendors and solution providers to split tunnel Office 365 traffic, and finally, what tool can you use to verify or validate VPN split tunneling for Office 365 connectivity. Let's start with Microsoft 365 network connectivity principles. I'm pretty sure you're very familiar with these principles because this has been discussed in the previous videos. The network connectivity principles were put together to address the branch office user connectivity scenario. The branch office user scenario is very similar to the remote user scenario because a remote user is nothing but a branch office with a single user in the branch. So by applying the network connectivity principles for the remote user scenario, you should be able to provision a connectivity model that is facilitating a productive environment for your remote users. The network connectivity principles states that you should be able to use the Office 365 endpoint categories to differentiate Office 365 traffic from untrusted generic internet traffic and define an optimized network path for direct connectivity. You should also be able to provision local egress for remote users. You should be able to provision direct connectivity, which means you shouldn't be happening the traffic. And you should be able to leverage the security services that are built within Microsoft 365 to enforce your security policies for remote users. So the Microsoft 365 network connectivity principles are the pivot for remote user connectivity guidance as well. Let's try to understand what are the expectations of a remote user. As a remote user, I'm expecting the best-in-class experience, which means I want to make sure that I have the best experience possible while connecting to Microsoft 365 services. And I cannot have the best-in-class experience without a direct connectivity. As a remote user, I also want my connection to be reliable. And this means that no matter the time of the day or night that I'm connecting to the service, I'm expecting a consistent and a good end user experience. As a remote user, I want to be productive. I want to focus on the task in hand and not worry about the quality or the experience that is going to impact my collaboration with my colleagues and dilutes my productivity. How can we deliver to the expectations of a remote user? By applying the network connectivity principles, you should be able to deliver to these expectations. And let's dig into those. Whenever we talk about remote users, VPN is an integral part of this conversation. VPN stands for Virtual Private Network. And let's look at the pros and cons of a remote user using the VPN technology. Let's start with the pros. A remote user is able to connect to their corporate network from a remote location using a VPN. This means a remote user is able to access application or services which are hosted within the corporate network from a remote location. Typically, these applications or services are not accessible directly from the internet. Now to the cons. A VPN is designed for small percentage of your workforce. So this means the VPN is limited in scale and bandwidth. When you have situations like COVID-19 crisis where you've got 80% or sometimes more than 90% of your workforce connecting from remote locations, this adds a lot of stress to your VPN infrastructure. And this can lead to a degraded user experience. So if you have users connecting to Microsoft 365 services using the VPN path, they are going to experience a poor end user experience. And this is totally unnecessary because services like Microsoft 365 are directly accessible from the internet. Let's look at some of the common VPN deployment models. And I think we can broadly categorize them as two different models. The first one is what we call as the VPN Selective Tunnel model. In this model, when you connect to the VPN, your default path is still the local interface. So the VPN is not the default path. As you can see on the drawing, the orange and the purple lines indicate connections to the internet and to the Office 365 endpoints. And the user is able to connect to these endpoints directly using the local interface. The only line that needs the VPN is the blue line, where the connections are sent via the VPN path. The blue line here represents connections to applications or services that are hosted within the corporate infrastructure and is not directly accessible from the internet. In this VPN deployment model, it does not matter if your VPN is switched on or switched off, because the user has direct connectivity to the endpoints on the internet and to other cloud services like Office 365. Here is another VPN deployment model. This one is called Forced Tunnel with no exceptions. And we see a lot of customers using this VPN deployment model. In this model, when the VPN is connected, the VPN is the only available path. So the VPN becomes the default path for all connections. As you see in the drawing, the orange line, the purple line, the blue line, everything is sent via the VPN path. So the remote user is dependent on the VPN to connect to Microsoft 365 services like Office 365 in this deployment model. And this is, bad for the end user experience because, the path to Microsoft 365 is taking a longer and a more stressful path. Having looked at the VPN deployment model, Forced Tunnel with no exceptions, let's talk about how you can provide some exceptions to that Forced Tunnel model and provision the direct connectivity that's required for remote users to Microsoft 365 endpoints. So in the slide here, you're looking at a model which we call as Forced Tunnel with exceptions. This is very similar to the VPN Forced Tunnel model that we saw in the previous slide. As you can see, the orange, the purple line, the blue line is all still sent via the VPN path, and the default path is still the VPN interface. The difference is, as an administrator, you can step in and define some exceptions that have direct connectivity path using the local interface. So as you can see in the drawing, the orange line that goes directly from the VPN client to Office 365 indicates the list of exceptions defined to have an optimized network path with direct connectivity using the local interface. In this VPN deployment model, it is recommended that you define these exceptions because if the VPN is enforced on the user or if it's always switched on, then the exceptions are necessary for the remote user to have a direct connectivity path to cloud services like Office 365 endpoints. Even if the VPN is not enforced, which means if the user has an option to switch off the VPN, it's possible that the user may get a direct connectivity path by switching off the VPN, but this will require user education, and switching off and switching on the VPN is not the best user experience. Effectively, you should be able to define a short list of exceptions that can bypass your VPN and instead take a direct connectivity path. Now, let's talk about Office 365 VPN Split Tunneling guidance. Microsoft came out with this guidance earlier this year to help our customers split tunnel Office 365 traffic. And by doing so, you're avoiding the risk of VPN infrastructure saturation. The guidance itself is divided into two parts. The first part is where we talk about the high-level strategy and approach. This is where we ask you to treat your remote users as branch office users. And the second part of the guidance is where we articulate the implementation details. Here, we are using the Office 365 endpoint categories and particularly the optimized endpoint set to split tunnel Office 365 based on IP ranges that are dedicated for the optimized endpoint set. By providing a direct connectivity path to the optimized endpoint set, you are not reducing or lowering the security posture for your VPN implementation, because the connections to the internet or the connections to untrusted endpoints or even the connections to Office 365 endpoints that are outside the optimized category is still going via the VPN path, and you are in full control of the traffic. The traffic to optimize endpoint set is often high in volume, and this is the traffic that's latency sensitive and requires an optimized network path. By sending this traffic direct, you are able to reduce the stress on your VPN infrastructure and enhance the end user experience for your remote users. Network traffic to optimize category endpoint set is still encrypted. It's still checked for integrity by the Office client application stack. And the connectivity is scoped to a limited set of IP ranges that are dedicated for the Office 365 services and hardened at the application and network layers. Office 365 VPN split tunneling guidance can be natively implemented with most VPN solutions in the market today. Microsoft reached out and worked closely with VPN solution providers and vendors in the market to come out with targeted guidance configuration templates to make the implementation of VPN split tunneling for Office 365 as simple as possible. Here is a list of targeted guidance that we have from some of our VPN solution providers and partners today. Even if you don't have your VPN solution provider or the vendor listed in the previous slide, it's not a concern. As I explained earlier, our implementation guide for VPN split tunneling gives you the details of how to split tunnel Office 365 traffic. The optimized endpoint set is the key category or the category that you need to prioritize to split tunnel Office 365 traffic. So the most important information you need to know is what is part of the optimized endpoint set. Here is a table on the slide that gives you the list of endpoints that are part of this optimized category. We've got 2 endpoints for Exchange Online, we've got 2 endpoints for SharePoint Online and OneDrive for Business, and we've got 3 IP ranges for the Microsoft Teams media traffic. The media traffic here refers to real-time traffic like audio, video, and screen sharing. If you want to have a complete list of IPs, part of the optimized category, you can use the PowerShell script, which is listed on the slide, to generate that IP list. And essentially, that's the only information that you need to implement split tunneling, irrespective of the VPN solution or the product that you're using for the VPN technology. Just keep in mind that these IPs are bound to change. We do have a monthly cadence, and you can use the endpoints web service to keep up with the changes and query the changes automatically as soon as we publish them. The common question that we get asked is, how can you verify or validate the VPN split tunneling for Office 365 traffic? The answer is you can use the Network Onboarding tool to verify VPN split tunneling. You can access this tool by going to connectivity.office.com. It's a browser-based tool. The purpose of this tool is to help our customers check their alignment with the network connectivity principles. But the tool also has 2 capabilities for remote users. First, it is able to detect the presence of a VPN. It can tell you if it's a selective VPN tunnel or if it's a forced VPN tunnel. And if it's a forced VPN tunnel, it's able to do some additional checks to tell you what traffic is being sent via the VPN path and what traffic is being sent via the local interface path. Here are some screenshots that help you interpret the output from this net onboard tool. As you can see on the top left, this is a scenario where there was no VPN detected, and the tool is just telling you that. On the bottom right, you've got a screenshot where the tool has detected the presence of a forced tunnel VPN, and it's telling you that the Exchange Online, SharePoint Online, and the Microsoft Teams traffic is all being sent via the VPN path. And obviously, this is not good for the end user experience. Here is another screenshot where the tool has detected the presence of a VPN Forced Tunnel. It's telling us that the Exchange Online traffic and the SharePoint Online traffic is being sent via the VPN path. However, the Microsoft Teams traffic is being split out and sent via a direct connectivity path. Let's look at some demos which will help you with the usage of this tool and interpretation of its results for remote users. Let's go ahead and look at a demo for connectivity.office.com. So I'll open the browser and I'm going to connectivity.office.com, and we can run this tool by clicking on the locate me icon here. That's going to locate my location automatically if the location services are enabled on your machine. If not, you can type in your location manually. Now the tool has done some basic test, and VPN detection is not part of this basic test. We need to run the advanced test. And before we do that, I just want to show you quickly that at this point, I'm not connected to any VPNs. I'm just connected to my Wi-Fi interface at home. And if I look at the routing table, you will notice that I've just got one default route, and that is on my Wi-Fi interface, which is interface index 24. So let me show you my interface table as well. So here you can see that I've got my Wi-Fi interface connected, and my interface index is 24, and that's the only default route I have for connectivity to internet. So at this stage, if I go ahead and run the advanced test in the tool for the VPN split tunneling detection, so let me go ahead and do that by typing in my Office 365 tenant name and clicking on run test. And that's going to download this exe file, and running this exe file is going to trigger the advanced test that we need for VPN split tunneling detection. And you'll see in a second that this is going to trigger those advanced tests. And you can see that the tests are now in progress. There's a bunch of tests that we run, and it usually takes a couple of seconds for the tool to finish all the tests. You can see that the testing is now in progress. But we don't have to wait for all the tests to complete. I think the VPN detection should have completed by now. So I'm going to minimize this and go into the details and solutions page to look at what's the result of the VPN. So here you can see the VPN is not detected, rightfully so, because I'm not connected to any VPN at this stage, and that check has passed successfully. So this is what we expect in the case of no VPN being present. Let's go ahead and look at a scenario where the tool is detecting the presence of a VPN. So in order to show you that, I've connected to my corporate VPN. So you can see my MSFT VPN is connected. This is a VPN Selective Tunnel. So which means even though I've got my VPN connected, my default path is still going to be my local interface path, which is my Wi-Fi path. So I should have direct connectivity to Office 365 services. And it's only some selected traffic or predetermined traffic that is going to take the VPN path. And these are primarily for resources within the corporate network. So I've gone ahead and run this tool, and as you can see here, the VPN is now detected. It's called MSFT VPN, and the tool has gone ahead and performed some additional tests for the VPN split tunneling, and it's found that my Exchange Online Optimize is split out. My SharePoint Online Optimize is selective tunneled, and Microsoft Teams Optimize is split out. So which means that At this stage, all my Exchange Online and all my Teams traffic is not going via the VPN tunnel. And for SharePoint Online, there's only selective endpoints that are being sent via the VPN path, but the majority of the endpoints are using my local interface path. So this is how the tool has detected the presence of a VPN, but although my VPN is connected, because it's a selective tunnel, I don't have anything to worry at this stage because I've got a direct connectivity to the optimized category endpoints. I wanted to show you a scenario where I'm connected to a VPN Forced Tunnel, and the default path is going to be my VPN path. So here is a situation where I've connected to my MSFT VPN full tunnel, which is a forced tunnel VPN. And once I get connected to this VPN, what happens is there is a VPN interface which becomes active. So you can see this in my interface table. And my Wi-Fi, which is basically my local interface, is also active. So since this is a VPN forced tunnel, what this is doing is this is also adding default route to my routing table. So you can see there are two default routes, and one is using my local interface. The second is using my VPN interface, and the route using the VPN interface has got a lower interface metric. So pretty much all my network traffic is going to take this particular path, which is my VPN interface path by default. So I've gone ahead and run the network onboarding tool, connectivity.office.com, and I've just finished running this tool, as you can see, and you can look into the results, and it clearly represents that I'm a user who's based in Dubai, but I've got my network egress somewhere in the UK. That's because that's where my VPN server is located for this forced tunnel VPN. And in the details and solutions, the tool has detected the presence of a VPN forced tunnel. It gives you the name of the VPN. And it is also doing some further checks to check for what traffic is being split tunneled. And it is reporting that Exchange Online, SharePoint Online, and Microsoft Teams, so pretty much all the optimized category set traffic is being sent via the VPN path, which is bad for the end user experience. So that's what the tool is reporting based on this forced tunnel VPN test. So you can see that it's pretty simple and straightforward to detect that the user in this particular scenario is going to have a poor end user experience because the path the traffic is taking is a longer and a more stressful path. And the right thing to do here is to split out Office 365 optimized category endpoint traffic. So they've got a direct connectivity path to those endpoints. Here is a scenario where we have once again connected to the VPN Forced Tunneling. It's a forced tunnel VPN called MSFT VPN full tunnel. So which means the default path is going to be our VPN path, and we expect all the traffic to be sent via the VPN path. And we can see that this is reflected in the routing table, where we've got two default paths, one via the Wi-Fi interface and one via the local interface. But what you also notice is that there are three routes added to the routing table. So these are for the Microsoft Teams optimize endpoint set IP ranges. As you can see, these are the IP ranges that we use for the Microsoft Teams real-time traffic, like audio, video, and screen sharing. And we have added these routes and we have forced them to use the local interface in order to send the traffic. And we did this by simply following the guidance which is provided in our implementation guidance document for VPN Split Tunneling. And we have simply used this PowerShell script to put those static routes in the routing table to split tunnel the Microsoft Teams traffic. So in this scenario, I've gone ahead and run the connectivity.office.com tool. You can see that it's still in a VPN Forced Tunneling scenario. So where the user is in a different location, the VPN server is in a different location, and the traffic is being forced via the VPN path in order to connect to the Office 365 services. And in the details and solutions page, the tool has detected the presence of a VPN Forced Tunnel. And it's also gone ahead and done the checks for the split tunnel. And this is where it's telling us that the Exchange Online optimized traffic is tunneled via the VPN path. The SharePoint Online optimized traffic is also tunneled via the VPN path, whereas the Microsoft Teams optimized traffic is split out. So this is due to the static routes that has been added to the routing table. And in a similar way, we could potentially add the routes for the IP destination ranges for Exchange Online and SharePoint Online, especially for the optimized category endpoint set. And we should be able to split out all the three major workloads and basically make them use the local path instead of the VPN path for a much better user experience. Hopefully, the demos have given you a good view of how to use the network onboarding tool for VPN detection and to validate VPN split tunneling for Office 365 traffic for your remote users. Let's go ahead and summarize what we have discussed so far in this video. You should now be familiar with the expectations of a remote user in terms of connectivity and experience, and why network connectivity is relevant and important for remote user experience. You should also be familiar with how you can apply the Microsoft 365 network connectivity principles in order to deliver to the expectations of your remote user. We also discussed the Office 365 VPN split tunneling guidance and how you can target the optimized category endpoints set to split tunnel the Office 365 traffic. By doing so, you are able to deliver the best-in-class, reliable, high-performing, and productive experience for your remote users. Finally, we looked at the connectivity.office.com, which is a browser-based tool that you can use to detect VPN split tunneling and validate split tunneling of Office 365 traffic. Here are some resources that has been used in this video for your reference. I put them on the slide. Hope you found this video useful. Thank you for tuning in.